use Euler's theorem to determine whether this function is homogeneous. All right? Let me just rewrite the function. 4x squared y plus 3x y squared minus x to the fourth over y. Now remember Euler's theorem, it says x times the partial of the function with respect to x plus y times the partial of the function with respect to y is equal to n times the function. Alright? N is the degree of homogeneity if the function is homogeneous. Now, I'm going to ask you to pause the video, write this down, and work it out. Okay, you're finished. Now, let's see partial of f by partial x is, this would be 2 fours 8 xy plus, when you differentiate this part, you get 3 y squared minus, when you differentiate this, you get 4x cubed over y. Alright. Now, what is partial of the function by partial y? Now, this is going to be, when you differentiate this part, you get 4x squared plus, when you differentiate this with respect to y, you get 2 by 3, which is 6xy. So that's 6xy minus, when you differentiate this part, you can rewrite this part as x to the 4 times y to the negative 1. And by the power rule, you multiply by negative 1. Negative 1 comes here. Negative x to the 4th y to the minus 1 from the old power, so it's negative 2. So what you will get here is negative x to the 4 over y squared. Alright? So it's x to the negative x to the 4 over y squared. It's negative minus negative x to the 4 over y squared. Alright, that part is rough work. Let me just erase it back. Okay, well, minus negative, so we can replace that with plus. Alright, now here, you must multiply the partial f by partial x by x now. So you're going to have x times all of this, 8xy plus 3y squared minus 4x cubed over y plus, then y times partial f by partial y. So you're going to have y times all of this, 4x squared plus 6xy plus x to the 4th over y squared. Alright, and see what it is. If you get a number times the original function, then it means that the function is homogeneous, and that number is the degree of homogeneity. So, or homogeneity. So what happened here now? This is 8, when you open the bracket, 8x squared y plus 3x y squared minus 4x to the 4th over y plus 4x squared y plus 6x y squared plus x to the 4th y over y squared. Alright, let's see what we can simplify and so on here. So We have all of this part. Y. Okay. So we have an 8x squared y plus 4x squared y. So we have this part down. We have a plus 3x y squared. So we have this part down. We have a 6xy squared, so plus 6xy squared. What else happened here? Oh, guess what? Y into y1, y into y squared was y. So we have a minus this, minus 4x to the 4th over y. So we have this part taken care of. Then this is plus x to the 4th over y. Alright. So we have all of those things there. So 8 and 4, 12. So we have 12x squared y. 6 and 3, 9. So we have plus 9xy squared. Negative 4 x to the 4 over y plus 1 x to the 4 over y. Negative 4 plus 1 is minus 3 x to the 4 over y. Let's factor out 3 from it. 3, open the bracket, 3 into 12, 4, so this is 4x squared y plus 3 into 9 is 3. So we have xy squared minus 1x to the 4th over y. Alright. So, let's compare it with what we had 3 times. We have 4x squared y plus 3xy squared, 4x squared y plus 3xy squared plus x to the 4 over y. Minus, x to the 4 over y. Good. So, this is really the function. So, it's 3 f of x, y. So, we can say the function is homogeneous. The degree of homogeneity with degree 3.